Hey everybody, Math Muscle back with a proof of the Pythagorean Theorem. We're going to go ahead and get started with, first of all, what is the Pythagorean Theorem? It's this formula that you probably saw since about the beginning of 5th grade or 6th grade. A squared plus b squared equals c squared. Now the assumption that we're running under is that we have a right triangle, seen here, denoted by this right angle, with legs of A and B and hypotenuse of C. This formula applies only if we have a right triangle. Okay, so what I'm going to do is I'm going to use some geometry with regards to similar triangles, as well as some basic algebraic manipulation to show you how we come up with this. So let's go ahead and get started. Okay, so I've got an image here, same triangle that I had on the previous page, where I've got leg A, leg B, and hypotenuse C. What I've drawn here is an altitude from this vertex over to that hypotenuse, creating a right angle. That's what an altitude is. I'm calling that length h. This angle right here between sides A and C I'm calling alpha. The side between B and C I'm calling beta. Now what we have then is we have two triangles, actually three triangles that are now created. Here's the first of the triangles. The second, and I'll kind of fill in some of the information here in just a second, but here's the angle beta, here's the angle alpha, here's side A. This side I'm going to call C1, and this side I'm going to call C2. And what I've done basically is I've taken C and I've created two sides such that their sum equals C, C1 and C2. Okay, and then I'm going to connect these with H so they share that side length. Okay, within any triangle, one of the things we must remember from basic geometry, and we're going to hold on to this C1 plus C2, that's going to come into play in a couple minutes, but we also know that the three angles within any triangle add up to 180. So I should have alpha plus beta plus 90 equal 180. That means then that alpha plus beta should equal 90. So if I have 90 here, that means I have 90 remaining. That means that these two angles, right here, these two angles must add to 90. That tells us that this must be the angle alpha. Likewise, in the other triangle, this angle must be angle beta. Okay? Therefore, now I've got similar triangles. In geometry, two triangles are similar by either angle, two pair of congruent angles in any two triangles give you similarity. This symbol right here means similar by angle. Therefore, these three triangles are all similar. So let's lay them out. Okay, I've got this triangle ABC with angle alpha, angle beta. Then I've got my second triangle, which is AC1H, where this is alpha and this is beta. And then I've got my third triangle. Of course, these are all similar to each other, where I've got C2 and I've got B and I've got H. This is angle alpha. This is angle beta. Okay, so whenever you have similar triangles, what you're allowed to do is set up proportions. Okay, so I'm going to set up a proportion with my original triangle, comparing it with my second triangle. So A and B and C. Okay, A corresponds to the side between alpha and the 90. So between alpha and the 90 would be C1. Okay, B corresponds to the side between beta and the 90. So between beta and the 90 is H. And C, my hypotenuse, corresponds with the other hypotenuse, which is A. All right, I'm going to just hold fast on that. Now I'm going to set up a proportion with the third triangle, again with the original. Okay, so A is the side between 90 and alpha. Therefore, it is proportional to the side between 90 and alpha, which is H. Okay, let me write these out. A and B and C. So we said that was correspondent to h, or proportional to it. Okay, b between the 90 and beta. Right here, b is between the 90 and beta, so between the 90 and beta would be C2. And then, of course, that leaves just b for h. Excuse me, b to go correspond to c, which is the hypotenuse. Okay, now, in the Pythagorean theorem, I don't see an h, so I'm going to get rid of anything that I see that has an h. But since I know that these are proportional, I can solve. So if a over c1 is congruent, or is proportional to c over a, then I can cross multiply. Therefore, a squared equals c times c1. Likewise over here, if b is proportional to c2, then as c is proportional to b, then b squared equals c times c2. Okay, now just side note, if x equals 3 and y equals 4, then wouldn't x plus y equal 3 plus 4? Yes. So if a squared equals c times c1 and b squared equals c times c2, then a squared plus b squared should equal c times c1 plus c times c2. Now what you'll notice, I almost have the Pythagorean theorem right here and ready to roll, but I'm going to factor out a c. If I take a c out of both terms, that leaves only a c1 and then only a c2. And what did we say at the very beginning? What is c1 plus c2 equal to? Yeah, it's equal to c. So a squared plus b squared equals c times, we said that this was equal to c. What's c times c? That's c squared. So a squared plus b squared is equal to c squared. Just awesome. Have a great day. See you in the next video.